you are with your deck of cards. I did give you a deck of cards, even a shortcut. So I'm going to go to 8 and start with 8. Didn't have this plan. Okay, so consider a deck of cards. So we're talking 52, right? 52 cards. And we're not going to state them in all three forms. I kind of just want you to be able to do it. So here we go. State the probability of drawing a 5. Right, so probability of drawing a 5. How many 5s are there? There are 4 5s in a deck of cards out of 52. And so that would be all I'm asking you to do there. This is on page 8. Probability. So again, I'm right now, it's all probability. So technically a fraction will suffice, right? So probability of a face card. You don't have to do this part here. I just like to always indicate like this is what I found, right? Probability of face. There are 52 cards. And how many face cards? 12, right? Okay. State the probability of drawing a numbered card. So probability of numbered card, there's 52, and I think there's 36 numbered cards because you got to go 52 minus 12 faces minus 4 aces. The aces are technically not numbered, so you're left with 36. Okay. State the probability of drawing a black jack. So probability of black jack, that'd be 52. And how many blackjacks are there? There are 4 jacks, right? Half of them black. Yeah, there you go. There you go. Sometimes thinking out loud helps, right? Like, I don't want to just write down numbers. I want you to actually know what I'm doing. Probability of drawing a face of clubs. Probability face clubs. There are 3, that's right. Under the clubs, just that suit, there are 3 face cards. So 352, there we go. There we go. State the probability of ace of diamonds. Probability ace of diamonds. Okay. There's just 1 out of 52. There's only 1 ace of diamonds. Oh, what about this one? I don't know if the printing didn't really do it justice, but this is saying not 8. Probability of not 8. That's another way of saying that with a bar. There's a bar on top there. So the way I do the not, I say 52 cards minus how many 8s are there? There are 4. Okay. Therefore, it's 48 of 52 cards that would not be an 8. Okay. So when it's not, I always go total minus the instances of it, right? That's how I would suggest you do that. Okay. 10, you know what, this table here, I will maybe do a couple percentage. You just multiply that by 100, right? That should be 89%. And then going to a fraction, do you remember how to do that? Right? There's 2 decimals, therefore you'll have 1 followed by 2 zeros. That's how you do that one. And that's the only one I'm going to do. The other ones, I believe I posted the key. And I did not, I'm not going to worry about reducing a fraction yet. I might, towards the end, take some time to review that because I think you should be able to do it before you graduate high school. Right? You should know how to do it. Georgina, so this is the one I really wanted you to focus on here. There's lots going on. You're buying bulk candies and found that 15 were red. There's some green, purple, and orange. So the first thing I would do right off the bat is like, hey, how many do I have in total? If this is a probability question, there's most likely going to be the need to find how many are there in total. And I don't have the key in front of me right now. So it's 25, 37, and then 50, right? 50. That's very important for probabilities, right? Total, there are 50 candies, right? So for A, the probability of randomly, it always has to be random, being red So probability of red, there are 15 of them over 50. Right? You can tell that 5 goes into both of them. So that's how you reduce. Like when it's easy, maybe I'll just take the time. So 5 goes in there 3 times, 5 goes in there 10 times, and this is the reduced version of it, which is 0.3, which is 30% exactly, right? If you asked to do it on a test, to have it in all formats, you should be able to do it. B, that's a probability of being green or purple. There's the word or, which you should have a plus there, right? So probability of green or purple. So you simply add the greens and the purples because you really don't care. Both of them will win in this case. So that's 22 out of 52 there. I don't know if you see that they're both even. So we can divide both of them by 2. And that would be 11. And that'd be 26. And that's actually as reduced as you can get it. Because 11 is a prime number. I don't know if you remember your primes. Those were your prime years, maybe. If distribution of colors, this is very important. I'm going to highlight that because usually there is one like this at the end. If the distribution is in a bag of 1,000 candies were to be the same, right? If the distribution, because there's like a ratio, right, that we have here, if that would be the same in a long, bigger scale, how many would you expect to be red? You're making a probability, prediction, sorry. You're making a prediction. So you're going to take the probability of, in this case, red, and you're going to multiply that by 1,000 candies. You're saying, hey, how much is it in the long run? So red is already, we can use this one, we can use this one, we can use any of them, but I'm going to use the one of these fractions because then you are guaranteed to use all decimals, right? So there we go. 300, there we go. It's exactly in this case, right? If it's a decimal, make sure you round it to a whole value. I don't know why I left so much space, but hey. And then we have at the bottom of 11, see here, consider the letters of the word probability. So this could be any word. If the letters making up this word were to be placed in a bag, state the probability of drawing an eye. So probability of eye. First of all, you need to count the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters. Okay, so that means that I have 11 options in total. And how many eyes are there? There are 2 of them, right? So that's how you would do that part. For B, probability of drawing a vowel. And so, yeah, 4, did you say? Yeah. A Y is not a vowel. Okay, that's not a vowel. So 4, so the O, the A, and the I's would be your vowels there. So 4 out of 11. So hopefully that helped you there. For question, page 12, this is very similar. So I'm gonna probability of buying a tube of brand A. So probability of A. How many tubes are there in total, guys? Help me out. Anybody figure out total? 75. Here, I'm going to use this. This is 60, 80, 155. Yeah, that's what I'm counted. Yeah, tubes. So that's 155 here for sure. And brand A is 75. So boom, there we go. So could you simplify this? You could divide both of them by 5 because they end in 5s. That would be what? 115, right? And then that would be 331, 15 to 31. That's as reduced as you can get it because 31 is a prime. Prime numbers are numbers that can only be divided by 1 and themselves, right? The number itself, that's a prime number. Probability of a customer buying a tube of brand C. I think you get it at this point. I always give you more than what you need, but so that'll be 57 there. That's as reduced as you can get it because 57 is, no, 57 can be divided by 3, but 155 can't. So let's just keep going. Set the probability, watch this one, of a customer not purchasing brand B. Probability, let's go like this, B not. So we go 155, and then 155 shows up again, and I'm going to subtract brand B from it. Okay, so I'm left with 132 over 155. Okay. That would be that. Not buying brand B. Okay. There's this, do you know Dimitri Martin, the comedian? Does that ring a bell, Dimitri Martin? So he says, if you really want to sell more like merch, like for example, welcome to Winnipeg, if you want to sell that shirt somewhere else, you just write not in front of it. So you go to any city, it's like welcome to not Winnipeg, and you can still sell it, right? Because he kind of, he's a nerd anyways. If the store sells 26 tubes, how many of brand A can you expect to sell? Prediction. Okay, this is just a classic prediction. So we're going to go probability of A, which we already have way up there, way up there. I'm going to reuse this answer. Don't use the reduced one because if you made a mistake, you carry that mistake with you. So I'm just going to use that one because remember, they're all the same. And you're going to need to help me out with this one. What do we have for this? Any brave? There we go. So you would expect 1258, 06, and something, but we would say, hey, we have to round that. So approximately this many tubes, right? You're expected to sell 1258 there. If 500 toothpastes are, how many of brand B can you expect to sell? Same idea. So prediction. Brand B, I haven't done that yet, so I'm just going to go 23 over 155, right, times 500. So you go 23 divided by 155. That's about 14%, right? 14.8 something percent, just to give you some perspective. So 7419. That's approximately 74 tubes. Okay, so that's how you do it. I said to go all the way to 15, right? I think it's still probably worth correcting it, right? Use a spinner below to answer. State the probability that the spinner will land on cat. So probability of cat, there are 1, 2, 3, 4, 5 sections, and it's 1 out of 5. Okay, decimal will be 0.2, and percentage will be 20%. State the probability that it will land on gerbil. There are 2 sections of that, right? I'm just going to go probability of G. Anybody have a gerbil? Right? No, they bite. So I learned it the hard way. We have dwarf. I have a dwarf hamster. My youngest has a dwarf hamster, so it's pretty cute little guy. If you spun the spinner 650 times, how many times would you expect it to land on fish? Try to see if you've already done probability of fish. If you haven't, then you need to do it here, right? Prediction. Probability of fish times 650. So probability of fish would be 1, right? 1 out of 5 chances of it landing there. So that'd be 1 divided by 5, which is 0.2 times 650. That's 130 exactly, 130 times. That is what if you do it randomly. You're not cheating. You're not like just spinning it just a little bit, right? Just a little tap. You're like spinning that thing random, like the same force every time, and it's random, right? What is the probability of the spinner not landing on fish? Probability of fish not? Well, it's as easy as 1, 2, 3, right? You go 5 minus the one fish that you have, so it's 4 over 5, which is 0.8, which is 80%. And remember, probability of it happening and not happening, right, should always add up to 1 or 100%, right? 1/5 would be 20%. So fish happening, fish not happening adds up to 100%. Remember that. So that should help you answer the questions. There's another deck of cards question. Someone missed that. Are we doing time-wise? You know what? Probably everything I'm going to do today is probably just reviewing what you just did. I hope you're okay with that. Consider a standard deck of cards. What's the probability of drawing a red card? No problem. I know this from Mr. Erickson. It's 50%. You can actually do that. But it's 26 red cards out of 52, which is 1 over 2, right? That's 0.5, which is 50%. Half of the cards are red. So the probability of drawing a red face card, probability of red face. How many red face cards? There are 6, right? 12 in total. Half of them are. I give you that little cheat, right? That little summary of a deck of cards. Have that on your study sheets. What is 6 over 52 as a decimal? Let's do a couple just so you don't forget. So this would be 1154, right? Watch here. The 8 turns that into a 4. So I tend to quite often round to 4 decimals there. And then I just multiply that by 100 to give me the correct. Both of them would be considered correct. Because it's not a dollar amount, we're allowed to do more than 2 decimals, but 2 is the minimum, right, in this unit. Slow down, Mr. Dixon. You're talking too fast right now. Okay. Probably of drawing a black queen card. There are 52. How many black queens? There are 4 queens. Half of them are black, half red, right? So this would be 2 out of 52. Or 1 out of 26 if you reduced it, right? 2 goes in here once, goes in there 26 times. So we can do that, right? 1 over 26. What is that as a decimal? It's probably going to be a small number. So that'd be 0.0385 is the 6 bumps that, so I consider 4 decimals, right? Which would be 3.85%, right? It does make sense. It's a very small chance of that happening because the amount of possible favorable outcomes is low. Drawing a queen of spades. Queen spades. How many queen of spades? There are 4 queens. There's a queen of diamonds, queen of hearts, queen of spades, queen of clubs, right? So there's actually just one queen of spades. And that's a very small, even smaller, right? That'd be 0.0192, which is 1.92%. Very small chance of that happening. Okay? So if you tell someone, hey, if you draw a queen of spades, I give you $5, right? Very small chance of that happening, right? State the probability of drawing a card that is not a club. How would you do this one? Did you try this one? How many clubs are there? 13 clubs, right? Remember, in this case, we don't have a visual, so we just know there are 13 clubs in a deck. So when it comes to probability of club not, you don't want club, you would say, well, there's still 52 cards. Then I'm going to take all of my cards and just take away the clubs because you don't want them. Not is like subtracting as well. So you end up with 39 out of 52. You took away a whole entire suit. That's 3/4, right, guys? 3/4. You took away 1/4 of the deck, so you're left with 3/4. How's that? State the probability of drawing a card that is not a red face card. Probability, red face. So I'm going to write red face and go minus. And you know what? Maybe that bar should remind you that you're going to have to subtract. Right? This bar is like, hey, I'm going to have to subtract. So there's 52 cards. And I'm going to take my 52. How many red faces are there? There's 12 face cards. 6 of them are red. Okay, so that would be 46 out of 52. I was hesitating there. Okay, say the probability of drawing a black 9 or a face card. So black 9 or face card, that's what it's basically saying. A black 9, there are 2 of them. And a face card, there will be 12 of them. Okay. So that'd be 14 out of 52. So I do get creative with a deck of cards, so be mindful of that. Okay. 15. I think by now you have that. I have this key, I know that for sure. So key posted, just write down key posted October 31st. Then if you really want to check this page, because I want to make sure I get to the odds a little right now. So just write that down at the top. If you really want to check, I have a feeling you already know by now because I've done a bunch of deck of cards. So let's go to 16. I don't know how far you got. You did all the way to the 20? Okay. Well, you know what? That's exactly. Sometimes students like, oh, well, Mr. Dixon's going to do it anyways, right? And so just wait for me. But actually better if you try it first. And then if you get them all right, way to go. You're doing okay. Okay, I'm going to go to 19. Go to 19 real quick. Below are the choices of donuts at a birthday party. The donuts are in a box and each guest must close their eyes to pick a random donut. And why am I doing this? Because otherwise it doesn't work. If you look, it's not random anymore. So probability is out the window. So we have, let's do our, are we going to need our total? I'm not so sure yet, but let's see. State the probability of someone randomly picking a honey dip donut. I do need my total. So this is 9, that's 17, and 3, that's 20. Total is 20 donuts. Okay. State the probability of honey dip. So probability of HD, anyways, it's 20, and there would be 4 of them. Perfect. That's 1/5, by the way, which is 20%. State the odds. Are you awake now? Because this is where a lot of students lose marks. When it comes to odds, I don't know what it is. I don't know what it is. I'm trying to figure out, like, why are we getting this wrong? So I'm going to try my best to make it so silly sometimes, like when I answer these, so that it sticks. So state the odds. I'm going to highlight that. This was probability, right? So we had our total there. This is odds. Okay, so that should right away click something in your brain. Odds of someone randomly picking a chocolate dipped donut. So I'm going to say this. Chocolate. 2, what's on the other side if you want? So we're interested in chocolate dip. What would be on the other side? Chocolate not. That is what odds compare. They, on the other side, we don't care, about the other individual numbers like honey dip, apple fritters, like all of that. We just care about, hey, all the chocolates on this side and all the non-chocolates on this side. So I always start with this one. How many chocolates are there? 5, right? 5 are chocolate. And what would you put on the other side? If it's not, what did I do? 20 minus 5. You know what a lot of times happens is this. Students just leave it like that. 5 to 20. And as soon as you have the total in there, it's a -1. Like I can't even give you half a mark because that's the definition of odds. It's like chocolate to not chocolate. So this is what should be written. Okay, this is, you can reduce that as well, just like a fraction. 5 goes in there once. Let's reduce it here. Reduced 1, 2, 3. Okay, we divide both by 5 in this case. So here's where odds get even more complicated. State the odds, but what's that other word there? Odds. Usually it's odds in favor, but now it's odds against. So it makes it a little more complicated. Odds against someone randomly picking a Boston cream donut. So let me say this. If the question had said odds in favor of Boston, then you would actually say Boston to Boston not. That's how you would place the numbers in that particular order. This is just an aside. Put a little cloud there. It's like, hey, I know odds in favor would be like that. Write it down somewhere in there if you've already used up space. Odds against, right? That means that you're going to have Boston on this side and not Boston on the left side. That's what the against does to the odds. It basically flips the numbers. And maybe I will use purple, like just saying, or pink. I always get my colors wrong. You would think that that should be a non-issue anymore, right? So this is not Boston, and then Boston is on the other side of the fence. I almost say like we usually are on the left, right? We write from left to right. Boston is now against you, so they're on the other side. So which number do I start with? I usually start with Boston in this case. So there'll be 8 Boston creams, and therefore this would be 20 minus 8. So you would have 12 to 8 like that. Let's reduce it. 4 goes in there 3 times. 4 goes in here 2 times. You know what? I'm telling you already, like there might be 1 or 2 questions on the test that ask you to reduce, but it would not be enough to like affect you significantly, and it would be pretty easy to do. It'll be something like this, right? So nothing crazy. So let's do this last one and then we'll call it a day, okay? State the probability against someone randomly picking apple fritter. There's that word against. So first of all, probability, and there's the word against. What's another word for against? You can say not. Of someone not picking apple fritter. You see what I'm doing here? Probability, odds, odds, and now it's back to probability. And a lot of students would just continue with odds, right? I don't blame you because even I have to be careful. So you got to call me on it. So probability of apple fritter not. That's what it's asking here. So we still have 20. I'm going to go 20 minus, how many apple fritters? Only 3. They're so good. Anyways, 17 to 20. What is it? 85%. All right. So this would be 0.85 or 85%. Thank you very much. I expect you tomorrow to be able to do some sort of AC involving these. And work, nothing. Just update your study sheet. Have the deck of cards on there, right? Make sure your notes are like up to date. It should be done all the way to 20. From the very beginning all the way to 20 at this point.